Assalamu alaikum. I'm Dr. Umbreen Rashid from Department of Life Sciences, IBBC University, Islamabad. The topic which I'm going to present today is protective effects of Begonia oliveri on gentamicin-induced alterations in glucose level of rats. First of all, which is gentamicin. Aminoglycosides such as gentamicin are a class of clinically important antibiotics which are used widely to treat infections, mainly against gram-negative bacteria like Pseudomonas, Serratia, and Proteus species. Aminoglycosides, in spite of their useful effects, have substantial ototoxic and nephrotoxic side effects. This drug causes reactive oxygen species production, which induces cell injury and necrosis via lipid peroxidation. The renal injury due to aminoglycosides has been reported to lead to liver damage. Medicinal plants have been used by all civilizations as a source of medicines since ancient times. They have been a rich source of medicines because they produce a wide array of bioactive molecules, most of which probably evolved as chemical defense against predation or infection. In many developing countries, traditional medicine is one of the primary healthcare systems. In the present study, the plant which we are going to study is Begonia oliveri. It belongs to the Zygophiliaceae family, which is about 25 genera and 240 species. In Pakistan, this family is represented by 8 genera and 22 species. It is commonly found in Khyber Pakhtunkhwa and Balochistan in dry hills and gravel mixed sandy clay loam. The common names Shella pugai in Pashto and Kerka in Balochi. In the indigenous system of medicine, this plant is used for curing cough, diabetes as a cooling agent, blood purifier, digestive system disorders, for blood vascular diseases, as well as for the treatment of cancer in initial stages. Diabetes is a chronic disease which affects millions of people worldwide. The WHO expert committee has aptly suggested that research should be aimed at investigating the traditional methods of treatment for refractory diseases like diabetes. In this study, effects of Begonia oliveri co-treatment were investigated on gentamicin-induced changes in serum glucose levels. The plant sample of Begonia oliveri were collected in April to May 2010 from Thamiya, Pakistan. It was identified by Dr. Salim Ahmed, and a voucher specimen was deposited at Herbarium of Pakistan, Museum of Natural History, Islamabad. The plant was collected as a whole and dried in shade for 1 month at temperatures 21 to 30 degrees centigrade. The resulting dried samples were powdered using a blender and kept at room temperature in polythene bags. The dried powder sample was soaked in methanol for 1 week at room temperature with random shaking and stirring. The filtration of extract was carried out by using Waldman filter paper. After combining the resulting filtrates, they were concentrated to get a solid gummy mass. The extract was stored at -4 degrees centigrade in airtight vials for further use. Now coming towards the experimental design. This pegged only rats were divided into 4 groups, and each group contains 3 rats, and treatment was as follows. The animals in the group 1 rats received saline daily once throughout the experiment. The animals in the group 2 received daily IV injection of gentamicin at the dose of 80 mg per kg body weight for 8 days. The animals in group 3 received 80 mg per kg of gentamicin. In addition to this, they also received 200 mg per kg body weight of plant extract, which was started 3 days prior to the gentamicin injections, and continued with 8 days gentamicin treatment. The animals in group 4 received 80 mg per kg body weight of gentamicin for 8 days, and in addition to this, they also received 400 mg per kg body weight of plant extract, which was started 3 days prior to the gentamicin injections and continued with 8 days gentamicin treatment. At the last day, the animals were sacrificed under mild anesthesia, and the blood samples were collected for analysis. The results were evaluated by one-way ANOVA using Statistica 8.1. Now coming towards the results of the study, gentamicin administration significantly increases the glucose levels as compared to the control rates. The treatment of methanoic extracts at doses of 200 and 400 mg decreases the levels of glucose towards control values. These are the results in the tabular form. Here you can see the treatment of gentamicin has significantly increased the levels of glucose as compared to the control, whereas the treatment of begonia at the doses of 200 and 400 has decreased the glucose values towards normal. This is the graphical representation of the results. It is suggested that the active principle from this plant could be useful in treating diabetes. The increase in peripheral glucose consumption might be responsible for the blood glucose lowering effect of begonia extract. Blood glucose lowering effect may also be improved by inhibiting proximal tubular reabsorption mechanism with kidney for glucose. Higher contents of flavonoids, alkaloids, terpenoids, and steroid glycosides have been really reported in antidiabetic and anti-hyperglycemic medicinal plants. Higher concentration of these phytoconstituents in the extract could explain a significant hypoglycemic effect, either separately or in synergy with one another. The results of this finding suggest the protective effects of begonia arborei against the gentamicin-induced glucose alterations, which justifies traditional use for the care of diabetes. These are the references. At the end, I would like to acknowledge Higher Education Commission, Islamabad, Pakistan, for providing us the funding to perform this research work, and Indigenous Scholarship Batch for implementing to PhD. Thank you.